Question 26. A solution of lead chloride Mr278.2 contains 1.08 grams of PbCl2. So why would they give me a mass and an Mr only to work out the number of moles of PbCl2? So without reading any further, let's do that now. So moles of PbCl2, moles is mass divided by Mr, 1.08 divided by 278.2. I've got 0.00388 moles of PbCl2. I've dissolved it in 100 centimetre cubed of solution. That's a bit of a red herring. I've dissolved it in some water. I've made a solution out of it, and in this solution the lead-2 chloride is fully dissociated into its ions. It means that the Pb has formed an ion, and the Cl's, the two Cl's, have formed ions, so it'll have formed Pb2+ and 2 moles, 2 lots of Cl- ions. What is the concentration of chloride ions? Well, for every 1 mole of this PbCl2, when it dissolves in water, 1 mole of this will release 2 Cl- ions. So the number of moles of PbCl2 is 0.00388. But when it dissolves in water, to make 1 mole of this will make Pb ions and 2 Cl- ions. Then it makes 2 moles of Cl- ions from 1 mole of PbCl2. So I need to multiply it by 2, 0.00776, to work out the number of moles of Cl- ions. What is the concentration? Well, the concentration is moles divided by volume. I do actually need the volume now. So concentration is moles divided by volume, 0.00776. And I need centimetre cubed in decimetre cubed, centimetre cubed in decimetre cubed if it's going from a small unit value to a larger unit value, like centimetre cubes up to decimetre cubed, and divide by 1,000. 100 divided by 1,000 is 0.1. So my concentration is moles divided by 0.1, 0.0776. So my answer is D, 7.776. 7.76 times 10 to the minus 2. The rate equation for an acid catalyzed reaction between iodine and propanone, there's the propanone, is this. The rate equation was measured for a reaction, a mixture of iodine, propanone and sulfuric acid at pH 0.7. So immediately I'm thinking, why would they give me pH as 0.7? Well, pH is minus log to the base 10 of hydrogen ion concentration, so they want me to work out the hydrogen ion concentration, otherwise they wouldn't have given me pH. So let's do that first. pH is 0.7 is minus log to the base 10 of the hydrogen ion concentration. So what I do is I reverse both signs, so minus 0.7 is plus log hydrogen ion concentration, and then I do an inverse log to get rid of the log. So I do minus 0.7 is log of H plus concentration, and then do an inverse log or a shift log, depending on your calculator, shift log or an inverse log of minus 0.7, and the H plus concentration will come out as 0.2. Now then, it says nothing changes. In the second mixture, the concentration of sulfuric acid was different, but the concentration of iodine and propanone were unchanged. So this concentration isn't changed. Assuming that the temperature hasn't changed, then the rate constant won't change. So the only thing that's changed the rate equals something that's unchanged multiplied by the H plus concentration multiplied by something else that's changed. If the rate has gone down to a quarter, then the H plus concentration must have gone down to a quarter, because the other things in the rate equation hasn't changed. So if this has come down to a quarter of what it is, then originally, then the H plus concentration must have come down by a quarter of what it was originally, because the other, the rate constant and the concentration of propanone are unchanged. So the new H plus concentration is a quarter of what it was. 0.2 divided by 4 is 0.05. What's it actually asking me now? The new pH. So pH is minus log to the base 10 of hydrogen ion concentration. This is the new hydrogen ion concentration. Minus log to the base 10 of 0.05 is 1.3. So your answer is B.